Okay, the other day we ran into some factoring problems, and I explained one kind thoroughly, and there's another kind I did not explain thoroughly, and I want to go back and talk about those. One kind I explained thoroughly would be, let's say you had sine theta, cosine theta, minus sine theta. And the nice kind like that are really easy because you can see that there's something to factor out right there. There's a sine in both of them. And you can factor that out and say sine theta times cosine theta minus 1. Why is that important? Why were we factoring things at all? Because now, for today's homework, we're going to set things equal to 0. So for instance, if I said equals 0, the nice part would be that now that it's factored, I can say this part has to equal 0. You know, you make two equations. Sine theta has to equal 0, and then this part has to equal 0. Cosine theta minus 1 has to equal 0. And then, is sine of theta ever 0? Oh, yes, it is. There's some spots where it's 0. Think about sine. Doesn't it go like this, back and forth, and every time it hits here, it's hitting 0, right? There's a whole bunch of times that would be the possible answer. Do you remember you can't make a triangle for that, though? So if I'm trying to solve this right now, I'm trying to figure out what angle would work for this. And I'm saying to myself, well, it can't be a normal triangle because one of the sides would have to equal 0. That's not a normal triangle, but it could be one of these guys. You remember this? So many things to remember on this last test. You just got to have like lots of basics mastered. Okay, so then if it's one of those are called quadrantals, then it's either this spot, which is 1, 0, this spot 0, 1, this spot -1, 0, or this spot 0, -1. And then which one is it? Is sine x or is sine y? Sine y. And if sine's the y, that means the y has to be 0. Which one has a y of 0? Well, not that one. That has a y of 1. Not this one. It has a y of -1. Where is y equal to 0? Well, these two. So is there possibly two answers? Yes, there is. And the questions today will all say something like this. Give all answers between 0 and 2 pi, and then they go like this. Let me just show you the little, they go like this, meaning it can be 0, and like that, meaning what about the 2 pi? Can't be 2 pi. Okay, so then I better not say this answer right here as 2 pi. I better instead choose what? 0. And then this answer over here wasn't going to be a problem because it's between 0 and 2 pi. What is it? That's pi. So 0 and pi. And then I'm only done with part of my problem. Now I got to go over to this side of my problem. And on this side of my problem, I set that equal to 0. Cosine theta minus 1 equals 0. Cosine theta equals 1. And if I put that as over 1, I got cosine is ka, adjacent, over, hypotenuse. And if the adjacent and the hypotenuse are the same size, I'm back in this same boat where I have to use these guys. So I'll make a new one of these. And where is cosine, which is x? Where is x equal to 1? Only at this spot right here. That's a nicer one. 1, 0. That's the only spot where x is equal to 1. And therefore, it's 0 or 2 pi? 0. And since I already had that in my list of answers, I don't have to write it again. It'd be kind of dumb to say 0 and pi and 0. That doesn't make any sense. I already had said 0 as an answer. Okay, so there we go. And this one happened to have two answers. If this had come out to a fraction, like 1 over square root of 2 or something, I could have ended up with 4 answers. These 2 answers from this side of the problem, and I could have ended up with 2 answers from that side of the problem. So today you can have as many as 4 answers. That's how hardcore this is getting. All right, so let's practice some more factoring. This is the kind of factoring that I did not talk about very much yesterday, or I should say Friday when I taught you the lesson. We did not talk about this very much. But let's go back to plain old-fashioned x squared plus 2x plus 1 equals 0. Do you remember how to do those? You just factor them. Take a moment and just factor that. Make sure you remember how to factor. Try it. This is going to get intense. You want to stay with me today, even though drawing ducks is more fun. All right. then I'd say x and plus 1 and plus 1. Would you agree? All right, and then from there I can find out that x plus 1, x equals 0. Bottom line is this is negative 1, that's negative 1. Okay, well ours aren't like that. Ours are a little more complicated, but let me show you why it's a lot alike. See if you can see the same exact pattern right here. Sine squared of x plus 2 sine of x plus 1 equals 0. Do you get the tie from the old stuff you used to know how to do to trig? That's why I want to make sure you are good at factoring before we move on to the trig, because you got to be able to factor trig statements now. So try factoring that one. It's the same exact process. And if it gets too intense for you, I do have a way to make it easier. If you're one of those kids that's looking at this going, there's just no way I'm doing that, then change it over into this and factor that out. And when you're done, just remember that you simplified sine x into just x. So if you simplify this at the beginning to make it just into an x here, it'll look kind of like this. Where did it go? Okay, it'll look like this. You'll say, okay, that's too complicated for me. I'm going to let sine x equal u. And I'm going to say u squared plus 2u plus 1. That is called a u substitution, and they use it in calc all the time. When they have something really complicated in calc and they want to simplify it down, they pull something out of it and take this and say, instead of using sines, let's just use u. Because now this should be easily factorable. So then you go, oh yeah, I can see it now. It's two sets of parentheses, u and plus 1 and plus 1. And then all you have to do is take your u's and put in what's form? Sine. And take this other u and put in sine. And then it's still equal to 0. And then we say this one has to equal 0. And since this one's identical, I don't have to do it twice. That'd be dumb. So sine x plus 1 has to equal 0. Sine x has to equal negative 1. Now ask yourself for a second, is that possible? Can sine come out to a negative? Remember what sine looks like? It goes like this. Does sine ever get to be like negative 1? Is that a possibility? Yes, it does. So I know there's an answer. Okay, what if it had been negative 2? Does sine ever get as low as negative 2? No, then you'd say undefined, because it's not possible. But negative 1, yeah, it can go that low. What's the highest and lowest it can be? Remember this deal? This is the range of sine. How high can sine go? Positive 1. How low can it go? Negative 1. So if you're ever outside that range, impossible. But the other way you can tell that is just by saying to yourself, can I have an opposite and hypotenuse in this situation? Well, normally the hypotenuses are biggest, but if they're the same like this, I can work with that. That's got to be one of these quadrantals. It's got to be here, 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 or here. Why don't you see if you can finish that guy? Try to figure out the final answer. So what we're trying to figure out is what angle can we use so that sine x will equal negative 1. And therefore this whole equation here will equal 0. So it's sine y, right? And if y is negative 1, there's only one spot where y is negative 1, right? Y is negative 1 down here. Now, is this one of those weird ones where we have to go like that? No, those are inverse problems. This is not an inverse problem. So it's just this spot right here. And what is that spot right there? 270, but we got to say it in 3 pi over 2. Yep. Why? Because y is negative 1 right there. 0 comma negative 1. The way they'll say the way that they want their answers is between 0 and 2 pi. And they'll go like this. It can be 0 and it can't be 2 pi. So am I between 0 and 2 pi? Yes, I am. But wait, is there another spot where y is negative 1? No. This is where y is positive 1 up there. This is y is 0, and that's another y is 0. So there's no other spot. A lot of times there's two answers, but in this one there's only one. Okay, so what are we doing? We're factoring things today. At the beginning, see how it looked like? I reminded you that they can kind of look like this if they're the simplest of all problems. But today they're going to look more like this. They're just going to have some trig in them. So you're going to factor them down, and they'll look like this once they're factored. Then we take each part and set it equal to 0. In this case, they were the same, so we only had to do it once. Set it equal to 0 because of this. And then once we get it solved, we a lot of times have 2 answers, sometimes as many as 4 answers, because sometimes this side gives you 2 answers, and then this side, if it's different, will give you a different 2 answers that work, and you'll end up with 4 possible answers. Yes, sir? Okay, negative pi. Okay, this answer right here tells you it only wants answers that are positive. When they say between 0 and 2 pi, that's a sign they don't want negative answers. If they did ask you for secant of something, I would rebel and try to figure out what sine is and then flip it. You know what I mean? Wait a minute, secant though. Secant is cosine flip, so cosine and then flip it. Yeah, I know, you know what I meant. Okay, so let's actually, I think the smartest thing, we've got so many practice problems here. I'm going to do just a little bit more with you just on general trig, like strategies that we've been learning, and then we're going to get right to your homework pretty quick here. Do you remember that if I said something like this, that I can split it up into 2 problems? I can say 2a over 2 and what? Come on. That's supposed to be a 6. 6 over 2. Sorry. 6. Maybe that's worse. Anyway, and then I say plus. Do you get that that splits up that way? And then these 2's would cancel. So it would just be a plus b over 2. I'll give you another one like that. Please simplify this one for me. 3m plus, what? Did I say something wrong last time? I said b and then I thought it was a 6? Okay, so I couldn't read my own writing, I guess. Okay. If it was a b, then I'd have to just leave it like this as b over 2. If it is a 6, then it would be 6 divided by 2 would be 3. But anyway, let's move on to this one. 3m plus 5 all over, let's say, 5. Now, some people that are terrible at canceling just think you can go, oh, these cancel, so the answer is 3m. Can't do that. And you can't also just go like, oh, the 3m, and then make those both 1s. That's not allowed. Why? Because you need to have a 5 in this one to be able to do that. But what you can do is you can break it up into 2 things. What did I just say a second ago? 3m over 5 and then plus 5 over 5. And then that 5 over 5 part can turn into a 1. Why am I bringing all this up? Because when you have a problem like this, cosecant of theta, it's supposed to be CSC, cosecant of theta minus secant theta all over secant theta, do you get how I can break this up into cosecant theta over secant theta minus, and then these guys together, what do they make? 1. Secant over secant, which equals 1. Now, is that all done? No, but you're closer anyway. All right. This part, cosecant over secant. You remember how, in general, if you move things towards sine and cosine, that generally helps? Okay, so let's move this towards sine and cosine. What's cosecant as sine and cosine kind of thing? 1 over sine. Over secant is 1 over cosine. Why is that good? Because then I can flip and multiply. You get how I get cosine over sine? Here, if I'm going to bring this up, flip and multiply, you get how that's going to become cosine over 1? And what's cosine over sine? Cotangent. Cotangent minus 1. That's the final answer. Whew. Okay. Now, yep, I know it's annoying. I've thought about it myself, but I stopped myself because it is technically, if you just say cosecant That is not mathematically defined. There is no, like, it's, obviously you can think of it as shorthand for the thing, but it's very likely at the end you would end up forgetting to put the theta back in. If you don't have an angle, then trig doesn't work. So it has to have some angle right there. It can be an x, it can be a theta. If you want to take any of the problems that are in x and change it to theta, it's okay. I personally have grown to like theta. All right, I'm going to show you a different way. I'm going to tell you who told me about this one. This was Mr. Thomas's idea, and he calls it the secret weapon. And I kind of like it. Do you agree that since the beginning, we've taught you to clear fractions? So if I can get rid of that secant, wouldn't that be a good idea? Because then it won't be a fraction anymore, right? So I like this idea of getting rid of the secant. So to get rid of the secant, it can't just times top and bottom by secant. That would make a secant squared on the bottom. I mean, what could I times it by that would make secant go away? Sine? Why sine? Why cosine? Because cosine is the flip of secant, right? If secant is really 1 over cosine, then when I times it by cosine, do you get that those two together, since secant is really 1 over cosine, then you're timesing it by cosine, and they're gonna cancel each other? All right, so that turns into 1. That makes our fraction go away. If I times the bottom by cosine, I have to times the top by cosine. So that's kind of cool because now that's gone. I have to admit that's a really good idea. But it's not like it just makes the problem all super simple. I still have to multiply this out. But another cool thing happens. Cosine times cosecant is not cool. It's just ugly. We'll finish that later. Cosecant times cosine, that does not work out just super nice until later. And then this cosine times this secant, do you really understand that cosine times secant is equal to what? 1. So then that makes it minus 1 because these two multiplied turn into just 1. So then it's close, and guess what this turns into? Same exact thing it did last time. It'll turn into cotangent. Because it's 1 over sine theta times cosine theta. And do you get how these guys turn into cosine over sine, which turns into cotangent? So it turns into cotangent of theta minus 1. Same thing as last time. Either way it works. I just wanted to show you that secret weapon, which I kind of like. Anytime you have something on the bottom and you want to get rid of it, there's something you can multiply by to get rid of it. So if I had sine over cosine, would you agree that's like the definition of tangent? It is tangent, right? Okay, but let me just show you that way I just showed you a second ago. How do I get rid of cosine? By multiplying it by secant. Secant. And secant and cosine, they multiply and make 1. So now it's sine times secant. What is sine times secant? Now you got to change everything to sine and cosines, and you'll find out it turns into tangent, just like we expected it to. So anyway, it's just a neat way to get rid of denominators. Now in this case, you wouldn't do it because sine over cosine is tangent in the first place. Could have done it a lot quicker by just saying it's tangent. The point is, anytime you want to get rid of a denominator, you can use any denominator that's out there. Has a foil to it, the yin to its yang, so to speak. So, no, that's different. That's different. If we want to get rid of a denominator plus 1, we got to do something more complicated. Let's say we had 1 over tangent squared. What's the foil of that? The flip and multiply by it, and it'll equal 1. The reciprocal of it. What's the reciprocal function to tangent? Cotangent. So if I multiply the top and bottom by cotangent squared, then that turns into 1. And you got cotangent. Couldn't you just done that in the first place in this case? Yes, I'm making these problems too easy, but that is equal to cotangent. So just showing you a different way, like you can get rid of the denominators by timesing by the reciprocal of it. Okay, enough of that. Now I want to do some more problems with you off the worksheet. So I'm going to hand out the new worksheet for today. I'm going to pause for a second while I hand that out. Oh, here we go. You have your worksheet now. Number 1, part A, 1A. I will cut out a few of these for you. In fact, I'll tell you right now before we forget, flip to the back side. I'm going to allow you to skip problems M and O and P, MOP. Skip M as in monkey, O as in orangutan, and P as in parsnip. Could have done primate, and then it would have all been primates. That's a good idea. All right, you're my last class of the day, though, so that's just not going to be able to happen for real, except you did it. Nice job. Number 1A, 6 sine theta, and then minus 1 equals 2, and then it says think. I don't have to write that all down. That's trying to just give me a hint. Think that it's like 6x minus 1 equals 2. For a second, do you realize if it was 6x minus 1 equals 2, wouldn't you just add 1 to both sides and then divide by 6, right? But look at this one. It's the same exact thing. I'm going to add 1 to both sides. So it's just as if the sine of theta was just an x. That's kind of the theme today. All right, so if I add 1 to both sides, I have 6 sine theta equals 3. Divide by 6 on both sides, because that's like an x. So I'm going to go divide by 6, and sine theta equals 1/2. Ooh, I know this one. I've seen this one so many times. Told you to memorize it. What is it? 30 degrees. Good. But then if you just say that, you're wrong. Because it's pi over 6, and you're also still wrong. Why? Because isn't there more than one possible answer? Look up in the directions. What does the directions say? Find all the answers between 0 and 2 pi. Hint, hint. There's probably more than one answer. When it says that, not always, but usually there's more than one answer. So is there more than one way to make sine of something equal 1/2? Oh, yes, there is. Here's the way to think of it. All students take calc. And sine's positive here and here. And so I'm going to get rid of these 2 spots because sine is not positive there. So if this is sine of theta is equal to 1/2, that makes this 30, and that's also known as pi over 6. And therefore, one of the answers is pi over 6. But there's another answer, and it's right here. Now, if you were thinking, wait a minute, can't we do that thing where sine's only allowed from here to here or whatever? That's for inverse sine. That's not this. This is regular sine, not inverse sine. So yeah, we're going to have another answer over there. And what is that answer? Well, if this is 30, then this is 150. But I don't want to say 150. I want to say it in radians. So 5 pi over 6. Good. If you're not good at that, you go like to the side and you go like this. Pi over 180. Cancel, 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 cancel. 5 goes in here. No, 3 goes in here 5 times. 6 times 5 pi over 6. 2 answers. And it's going to happen a lot today. Then not on this one. There's only 2 answers on this one. There'll be 4 answers when you get to problems that are factored like this, because there'll be 2 answers for this and 2 answers for that kind of thing. But we'll get to that in a moment. Let's move on to problem 1B as in banana. Kind of a jungle theme going today. 2 cosine theta equals square root of 3. So just think of this as like an x. So wouldn't you start by dividing by 2? I would. Cosine theta equals root 3 over 2. I've seen that before. Square root of 3 and the 2. That's probably that 1, 2 square root of 3 triangle. It's probably a 30 or a 60. I better draw it, though, to make sure I know what I'm doing here. Oh, students, take calc. Cosine's positive in here and here. And so those are my 2 places that should work. So I'm making a triangle here. Cosine is adjacent over hypotenuse. And that makes that a 1. That makes that 30. That makes this pi over 6 again. And should I just automatically say the other answer? No, because the other answer is down here this time. And that's all the way around here, which is just one little pi over 6 short of 12 pi over 6s. So therefore, it's 11 pi over 6. If that doesn't work for you, then you've got to do it the old-fashioned way and say this is 330 degrees. Therefore, multiply it by pi over 180, and you'll find out that once you reduce it all, it comes out to 11 pi over 6. Okay. Let's do one that works out to be a quadratic kind. Let's do G as in gangster. 1G. I don't think we're in the jungle anymore, unless we call it the concrete jungle. 2 sine of theta plus 3 sine theta minus 2 equals 0. Now, some of you are going to be able to hang with this without any kind of substitution, but if you want to make this look a lot easier, just let your sine be u, and then you'll have 2u squared plus 3u minus 2. That's a lot easier to factor. Some people use x, and I understand that because we use x a lot, but I'm using u because in calc they always do what are called u substitutions. So I'm just getting you used to it. It's the standard letter for substitutions. So I've pulled out the sign and put in a u. Now I'm going to have to put it back in at the end, but I'm going to factor this guy the old-fashioned way. 2 sets of parentheses and a u, maybe a 2u here, and a u here. And then I have to make it a 2 and a 1. I just play around with it, see if I can find it. I put a 2 here and a 1 here, and one of them minus and one of them plus. Outside 4u, inside minus 1u makes 3u. I got totally lucky. If I had it wrong, I'd have just kept rearranging these numbers here until I figured it out. But I got it. So am I done? No. Because I have to change this back into sine. So this is 2 sine of theta minus 1. And that's set equal to 0. And then I do the other side, which is right here. Sine of theta plus 2 equals 0. And I'll give you a hint. One of these two is impossible. Can you tell? Which one? The one on the right. Because sine theta equals negative 2. How can sine ever go down to negative 2? It can't. And therefore, that one's impossible. This one, however, can be solved. You'd add 1 to both sides. You'd divide by 2. Okay, so on this one, let's see. Add 1 to both sides. You'll quickly notice it comes out a lot like one of the other problems we did just like 2 minutes ago. You'll have 2 answers for it. We just did one just like this. All right. So how about one on the back side? If I flip it to the back side, let's do L, as in, what else is in the jungle that starts with an L? Leopard, lions, all right, lots of choices there, very good. What? Lemurs? I don't know, I suppose. All right, so I'm going with L. Secant squared theta minus 4 equals 0. So that means secant, oh, wait a minute. Should I put this on the other side? I don't think so. You know why? Because this will factor nicely. Right away, it'll factor. Recognize this, something squared and then something that's a perfect square? It's exactly like x squared minus 4 equals 0. And you can make that into x plus 4, or no, x plus 2 and x minus 2. You know what I'm talking about? Okay, this is a pattern that we've done. It's called the difference of squares. 2 things that are perfect squares and a minus in between. We've done that so many times. So now, you see it again. So now, it must be secant theta minus 2 and secant theta plus 2. Now, if you're like me, you probably don't like secants because they're harder to figure out than like sines or cosines. But let's just go with it a little further. Secant theta minus 2 has to equal 0. Secant theta has to equal 2. And now is your moment. Replace secant with something else. What? 1 over cosine. Theta has to equal 2. And now, you really don't want to have secant in your problem anymore. So I'd rather have it. It is yes, but that's not where. Okay, I see what you're saying. I see what you're saying. You're saying we could have made this a 2 over 1 and then draw our triangle for secant, right? Yes, yes, you can. And from right there, you could draw a triangle. For me personally, it's unless you remember Cho Sha Kao, which is the whole way to remember SOHCAHTOA, except for sine or secant and cosecant and stuff, that gets pretty intense. I personally would rather do this. You can do it that way if you'd like. So I'm going to now multiply both sides by cosine, and I get 1 equals 2 cosine theta, and then I'm going to move the 2 back over to the other side, and I have divided by 2, cosines alone. I know how to do cosine, and it's equal to a half. Well, if sine of theta is a half, it comes out to 30. What do you think cosine of theta would come out to half? Cosine of what? 60. You are correct. Do you think there might be another answer for that? Yep. So we go like this, and we say, okay, we just did the answer for that, and it came out to 60. Would there be another spot? Well, all students take calc. That's the other spot where cosine is positive. And if that's 60, then it must be 300. And so 60 is one of the right answers, but you should change it to pi over 3. And then this is going to be 300 degrees, which is 5 times bigger, by the way. So therefore, if you just think about that, if it's 5 times bigger than 60, then it must be 5 pi over 3s. That makes sense? All right. So, oh, we just did one side of it. Now I got to go back up to this one and do the exact same thing except for a plus. Oh, depressing. So, do you see how intense these can get? Do you see why that last test might be a pain in the butt? So many steps. So I just got done with that whole thing, and I'd only done half the problem. Because now I got to go back to the other part right here, set it equal to 0, and do the same exact thing, except it's going to come out to the negative of it. So it ends up coming out to the same exact thing, except with a negative, right? So why don't we save some time and say cosine of theta would have to equal negative a half. And then I can draw my picture and figure out the 2 answers that we're going to make that work. All right. So, for some of you, this is the hardest math class that you'll ever take. Some of you guys are going to move on to calc. Okay, some of you guys aren't. So for those of you that aren't, this is the hardest test of the hardest class in math that you'll ever take. So of course, it's going to be a little bit of a challenge. Some of you guys move on to calc, and then some of you are going to say, actually, calc I find easier than pre-calc. Some people say that. I have heard that several times. I don't always hear that. I sometimes hear people say, calc just killed me after pre-calc was hard enough, and then calc just put me out of my misery. But some people move from this class to AP Calc and get straight A's. So you've got everything you need after this class. And in fact, this trig is high enough level that you don't even need to have this high a level of trig when you're doing your calc. So we'll get into more advanced trig than this, don't get me wrong, but what I'm saying is this particular test is hard enough that I think I can safely say that you won't even have to know any trig beyond this in calc next year, which is, calc has a lot of trig in it. So anyway, yes, this is a hard test. Respect that, and therefore try hard, work as hard as you can when you are doing your, practice problems, and it should all work out okay. It's not, but it won't be an easy test, no doubt about that. All right, hold on just a second here. I'm going to pause. Okay, so let's finish this one off. So this one, if we've got this coming out to negative a half, that means all students take calc. Where is cosine negative? Well, where is cosine positive? Cosine's positive here. And, I just got dyslexic there. All students take calc, sorry. Cosine is positive there and there. So therefore, my 2 triangles that, yes, will have a 60-degree angle, but they're going to be like 60 degrees like this, then this must be 120, and that must be 2 60s. Each 60 is pi over 3, so 2 pi over 3 is one of my answers. And then this other one down here, also a 60. And so therefore it's all the way around here, which is 180 plus 60, which would be 240. And if it's 240, you can do that by, I'm going to do it this way, pi over 180, do some canceling, cancel, 24 over 18, 6 goes in there 4 times, 6 goes in there 3 times, 4 pi over 3. All right, that's pretty intense stuff. So I did cut off a few because I felt like this would not be realistic that you could get that all done tonight. So finish the ones except for MOP, MO, and P, and keep trying. The only way these work is you struggling through them. If you quit after 15 seconds and go check the answer key, that's what's going to happen to you on the test too, except you won't be able to turn to the answer key. You'll just be like, I don't know what to do. You have to learn how to fight through these. Otherwise, if you're used to just getting the answer really quick, you'll be in big trouble on the test where you will have to try to fight through it and keep trying different things. All right, I'll pause for a second. The question was, is this type an R3 type question? Yes, this is expected. This is not just like over the top R4 kind of thing. This is actually on there. You have these kinds of questions, yes. And a lot of times you'll have answers where you'll have 2 or 4 possible, or 4 answers that you have to come up with. And sometimes kids will get 3 out of the 4, but they'll screw up the last one, and yep, it's wrong. So it's tough. Yes? It's a good question. There are times when you get extraneous answers on these. We haven't hit any yet, but you're going to have to learn how to recognize when there's extraneous answers. Yes. So you can have like 3 answers sometimes instead of 4. All right, that's all I got for you for now.